everyone, my name is Sadie and welcome to Resonance Tutoring. Today I wanted to share an organic chemistry study tip with you guys. When I used to teach this class, sometimes I would notice that students would find an important table either in the textbook or in the lecture notes, and then on exam day, I would watch them flip to their scrap paper and completely copy down the entire table from memory. It was actually really impressive how much they were able to memorize, but I do have to admit, I don't think it's the best way to study the material. So, if you're looking for ways to improve your study techniques, or if you're sitting here thinking, oh my gosh, I could never memorize all of that, don't worry, you don't have to. I'm going to tell you about a technique that is easier and actually more effective than memorization. So in my personal opinion, the average organic chemistry student is relying too much on memory and not enough on intuition. Now, what do I mean by that? Intuition, that doesn't sound very scientific. Having good chemical intuition means that you have such a solid understanding of the foundational principles of chemistry that when you're posed with a question, you don't have to remember what the answer is, you're able to infer what the answer should be. And this makes sense if you think about the greatest chemists in the world. They're not earning Nobel Prizes because they managed to memorize the solution to the hardest chemistry question. They're exploring questions that we don't know the answer to. So these are people who have very finely tuned chemical intuition that allows them to make hypotheses and design and propose research experiments that can give really exciting results. And you might be thinking, Sadie, I'm not trying to win a Nobel Prize, I just have to pass this class, and trust me, I get it. But memorization alone is probably only enough to maybe get you through Intro to Chem. If you're looking to do well throughout the entire organic chemistry sequence, if you want to be good at synthesis problems, and especially if you are majoring in chemistry, you're gonna have to start building your intuition. So let's start by only memorizing what we absolutely have to. This is primarily going to be vocabulary. Chemistry is a lot like a second language, so you have to know what the words mean. So you'll need to memorize your definitions, the names of your functional groups, some named reactions and specific reagents, and you'll probably also need to memorize at least a few important pKa values, and possibly more if this is something that your particular professor likes to test on and really emphasizes. But for mostly everything else in chemistry, it's more important to understand the concepts and how they work. There are really two key concepts that build the entire foundation of organic chemistry. Those are steric effects, which are related to the shapes of molecules, and electronic effects, which would be things like resonance effects, inductive effects, electronegativity, polarity, anything like that. And if you know these concepts really well, you can use them to explain every trend and every reaction that you're going to learn. These concepts are typically taught within the first week or two of class, so it's important that you start off strong and really pay attention during those first couple weeks. And then it's also important that as you learn new concepts, you're tying them back into these ideas and knowing how to explain them using either sterics or electronics. So let's say you get a question like this. Which carbonyl will react faster with a nucleophile, a ketone or an ester? If you don't know the difference between a ketone and an ester, you're stuck. If you don't know what a nucleophile is, you're stuck. But as long as you know your vocabulary, you don't have to memorize that a ketone is more electrophilic than an ester. You can simply look at their structures, and as long as you understand the resonance effects, it's almost obvious that, hey, look at that lone pair. It's definitely going to do some resonance stuff. It's not as electrophilic. Nucleophile would have a much better time going toward that ketone. It starts to become intuitive. Another example might be, you don't have to memorize that an SN2 reaction will invert your stereochemistry. If you understand the mechanism of the SN2 reaction, then the effect on stereochemistry is self-evident. And if you understand the sterics and the electronics of your starting materials, then the way that they're going to interact will even start to become intuitive as well. Another thing I don't recommend memorizing would be NMR shifts. If you look at those tables of NMR shifts, they're great when you're first starting out, but if you're trying to correspond all of these random ppm values to different functional groups, there's a pretty good chance that you're going to get some things mixed up. All you really need to know, if you understand electronegativity, is that in an NMR spectrum, more electronegative atoms will shift things downfield. From there, you can infer where things are going to show up relative to one another based on what kinds of electronegative atoms they're close to. I'm actually working on a video where I go more in depth with my recommended strategy for learning NMR shifts. So if you're interested in that, make sure that you're following me. So really the key takeaway here is that you can't memorize everything. At a certain point, you have to prioritize where you memorize and where you use intuition. And the two things to always keep in mind are sterics and electronics. So hopefully you found this video helpful. If you did, please give it a like and subscribe. And if you're interested in an online tutoring session with me, my contact information will be at the end of the video.